Good afternoon, everyone. So we will wait few minutes. Let's see other are joining. After that, we will start this live session. Hello. Hello. Am I audible? Yes. Okay. I hope the screen is visible to everyone. Okay. Thank you. So good afternoon, everyone. So welcome to this second live session of this fluid mechanics course, and I am Niloy. So today we will explore some concept on this fluid statics, and this is the second live session, and some of you may have appeared for this first session, where I have discussed about some basic concept of fluid mechanics, properties of fluid, and fluid flow analysis, and we have solved few numericals. And if someone misses this thing, so you can go through the link provided by this NPTEL, and accordingly you can find out this recorded lecture. So as you know that these courses is interdisciplinary courses where civil student, mechanical student, chemical student can also uh, have to study this subject because it plays a vital role in many problem solving approach, like in industrial application or even in real life problem. Whatever you are seeing is based on this fluid flow problem, so it is quite essential. If water is coming out, say if water is coming out of the tap, so it's also a problem, and you need idea of this fluid mechanics to know how to what are the how this physics, underlying physics is working or not. So these are the concept we will discuss in this course. So as already many of the student has enrolled in these courses, so our so you have still opportunity to register for this exam and get the certificate from this NPTEL. So if you want to sit for this examination, then please enroll quickly. So before diving into this week content, uh, so let me tell one thing, that these are while discussing about this topic, I will solve few numericals because as this uh, assignment, as this live interaction session will help you to solve the assignment that has been provided for these courses. So basically the problem that I am going to discuss is the previous year assignment. So if first I will show a question and will explain the concept based on this question, and after that I will give you a few minutes time to solve, and and after that I will show you how to solve this question, right? And if you have any problem, first raise your hand in this chat box, or you can write your question in the chat box, or even you can on your mic and ask this question. So these are the three concepts. The first is the concept of this fluid hydrostatics. Next is the measurement of pressure and hydrostatic forces. So the second concept is quite important even for the designing of pipelines and all these things. The second concept is vital, and the third is the buoyancy, meta center, stability, and rigid body motion. So this concept will help you. This concept is quite necessary for ships, even it is if it is flowing through high tide. So this concept is essential to maintain the stability of a ship. So initially the first few questions are quite simple, and after that the level of toughness of the question will increase. So let us start with this first question. So what this first question tells in this first question, the question is this: Archimedes principle is and are. So these are the four options. So I guess many of you have attended this lecture and have go through this lecture provided by Professor Shubhashis sir. So as you have gone through this lecture, so I hope that you will be able to answer this question. Okay, so please try to answer this question in this chat box, and accordingly after this I will analyze this question. So Mr. Nitish has answered it as D. Okay, good. Yes, the correct answer is option D. Why? Because as you know this, if I explain about this Archimedes principle, so what it states. So it basically states if we have an object, say in a body, in a fluid. So if this is the fluid, if there is any body, so if it is fully submerged or if it is partially submerged. So this is partially submerged, this is fully submerged case. So if it is fully or partially submerged, it will always experience a upward buoyancy force. So this buoyancy force can be represented as FB. Okay, so this buoyancy force, why this buoyancy force is generated? This is because as we are dipping this solid body into this water, so this weight of the fluid is displaced by this object. Say initially if before putting this solid into this water, say the level of water is up to this. So after putting this solid, its level increases. So that means its weight of the fluid is displaced by this object. So according to this Newton third law, every action has an equal and opposite reaction. So that's why a buoyancy force comes into this scenario. And similar is the case for this. Similar is the case for this case where it is partially submerged. So that means option, what is the option A? A floating body displays its own weight in the fluid in which it floats. So okay, it's right. Next is the a body immersed in a fluid experienced a vertical buoyant force equal to the weight of the fluid it displaces. As I have said that this buoyant force is because of this displacement, because of the weight of the fluid it displaces. And what is its direction? Its direction is vertically upward. But in this in the third option, it is saying that it is an horizontal. So this option is wrong. So basically A and B are correct. So that's why the answer is option D. Okay. So we are moving to this next question. So in this question, it is tells that in the hydrostatic or shear free case of fluid, the pressure change in the horizontal and vertical direction should be dash and dash respectively. So you have to fill this gap. So again, I am giving you 1 more minute to try. So please try. Uh, so Mr. Nitish has answered it option B. So he is saying that in the horizontal direction, it depends on the gravity, it depends on density and gravity, whereas on the vertical direction, it is zero. So see this concept. So let me represent it in three directions. So say this one is your x, this one is your y, and this one is your z. Okay. So basically, first is that in a hydrostatic or shear free case of fluid, what basically it is? It means that uh, in a fluid static, in a fluid static, what it is? It means the fluid is at rest, and there is fluid static means it is at rest. Okay, and there is no shear force because since it is a rest, no flow is there, so no chances of any stress. That means in the horizontal direction. So see, if this is an water body, So this one is your horizontal direction, right? This one is your x. So as there is no shear stress, so there is no chance of change in pressure. Okay, so that's why in x direction, so there is no change in pressure. If you move from say this point to this point, there is no change in pressure. So this is for x direction, and consider it is a three-dimensional. So in the z direction also, the z direction means also it's an horizontal direction. So in that direction also there is no change in pressure. However, in the vertical direction there is, hello. Hello, hello, who is this? So, Nitish, you got this point that in the horizontal direction, as there is no shear force, so the pressure variation is zero. But in the vertical direction, say in the vertical direction, if this is a fluid, in this fluid, if I talk about this fluid, so this is 1.1 and this is point 2. So point 2 is below this point 1. So point 2 experience some forces. Why? Because of this body force or the gravity, right? So that's why the pressure at point 1 and 2 can't be same. Okay, that's why there is change, and this change can be written as minus rho g. So that means in the vertical direction there is variation. Why this variation? This variation is because of rho is the density, g is the gravity. So that's why in the horizontal direction it should be 0, and in the vertical direction it depends on density, gravity and depth change. So option D is the correct one. So I hope you got this point. Yes, Nitish, it is option D is the will be the answer. So next I will move to this third question. So up to this two question, any confusion or any doubt you can ask. Then I will move to the third question. Okay. So I am moving to this third question. So in this third question, so it's basically a calculation that is related to the previous one. So in this question it is asked, see Dauki Lake, a fresh water lake near Shillong, India, has a maximum depth of 30 meter and the mean atmospheric pressure is 91 kilopascal. So you are asked to find this absolute pressure in kilopascal at its maximum depth. So specific weight of water is given, right? So you have to find out this absolute pressure. So before solving this question, I am explaining a concept that is absolute pressure and atmospheric pressure. What is the difference between atmospheric pressure, absolute pressure and gauge pressure? So basically see, if this line represent this atmospheric pressure, that means the pressure at the normal condition. Right now what is the pressure in a normal environmental condition? That is referred to as atmospheric condition. Okay, so see, inside a vessel, say any vessel is there, there is the pressure is quite vary from this atmospheric pressure. Say the pressure point is here, right? So this is P. So this P is quite different from this atmosphere. It is greater. Okay. So this difference is known as gauge pressure. Okay. And this pressure, and that means this P. If you have to ask to find out this pressure P, so P absolute, I represent absolute as ABS, equal to P, I can write P ATM plus P expression. So if say sometime you can find in the question that this atmospheric pressure is given as 0. So if somewhere you find atmospheric pressure is 0, that means it is the gauge pressure, not the exact atmospheric pressure. Okay, so please use this concept and try to solve this question. Okay, Mr. Nitish has answered option C. So other please try. Okay, I'm solving it. Say in this question, what is given? See the okay, say it's I represent this as the lake. Okay, has a maximum depth of 30 meter. That means it is given as 30 meter. So it basically is the height. Okay, h equal to 30 is given. So also they have given atmospheric pressure P ATM is given as 91 kilopascal. So you are asked to find the pressure at this point, right? So what I have said in this earlier slide that in a vertical direction this pressure changes. So if a pressure at this point, say this is 1 and this is 2. So pressure at 2 should be more than pressure at 1, right? So that is, and this change in pressure is because of height and gravity. So that's why it is rho g h. Okay. So pressure at 1 is 91 kilopascal. 91 kilo means 30 should be there. And density, we know density of water is okay. So see one thing, not density. So they have already given the specific gravity, specific weight of water. What is specific weight? Specific weight basically means this rho g is term is fully known as this specific gravity. So this rho g is given as 9790 into, and the height is 30 multiplied by 30. So after solving you will get this answer. Okay, so after solving, you will get the answer as 3847 W. This will be the answer in Pascal. But in the question, it is asked to answer in kilopascal. So that means it should be divided by 1000. So that's why option C is the correct answer. I think to understand this concept, if anyone have any issue or any problem regarding this, please raise. So if you are okay with it, can I move to the next one? Hello. Oh, okay, okay, surely. Okay, surely. So to understand this concept, say right now in the atmosphere, certain pressure is there. Okay, so that pressure, what may be the value of that pressure, it will change in everyday life. Today at 40 degree, what will be the pressure at a point, and what will be the pressure tomorrow, that will be quite different. So whatever be the that pressure, say we if we represent it as PATM, right? I represent it as PATM. So that is say you are from which state? Uh, Jharkhand. So say in the Jharkhand, whatever be the pressure, if I talk about Odisha, in Odisha the pressure is different. Say this is the pressure of Odisha and this is the pressure of, this is the Jharkhand pressure at the Jharkhand. So if I observe this pressure of Odisha is is more compared to uh, Jharkhand at a certain day, right? I just assume this thing. So I consider this atmospheric pressure, I consider the pressure of Jharkhand at my reference. So that's why this is atmospheric pressure. This means this is the real value of the atmosphere. And the change between these two state, that is known as gauge pressure. Okay, that means the difference where the pressure of Jharkhand is considered as atmospheric pressure. Okay, that's why in real life what we do, that if somehow somewhere you find P of gauge equal to 0, that means it is the atmospheric pressure. Okay, so this is the gauge pressure. And talking about this absolute pressure means real pressure. So if the pressure value of Jharkhand is known and the gauge pressure is known, so you can find out this pressure of Odisha. So that pressure of Odisha equal to P ATM plus P gauge. So that value, this is known as absolute pressure. Understand this concept? That is basically the difference. The gauge pressure is basically the difference between the atmospheric pressure and pressure at any point. It may be above 1000 meter above the sea level, it may be 500 meter above the sea level. So always you consider, like in the normal atmospheric condition is considered as 1 bar. So that is a reference line, that is 1 bar. So we know that thing, but in the Gauss scale it should be 0 because it's a reference line. So whenever anything is a reference, we consider it as 0. So so it's like in a scale. Say this is a scale, so it has some reading. So initially it is 0, 1, 2, 3, like that. So consider this is broken at this part. This is broken. So if you have to measure, you will consider 1 as. 0 reference. That means it should be 0. So that is the concept with this pressure also. Okay. So if it is okay, can I move to the next one? In which case? Yes, yes. In gauge pressure is equal to yes. Yes, 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 yes. Because that is because of the gravity, the pressure will increase downward. So that's why it is multiplied by. Okay. So I'm moving to the next one. Hmm. So it's almost a similar question compared to the previous one. So here a manometer. Huh. So specific gravity means rho g. Sorry, specific gravity is a non-dimensional form of density, or it is known as relative density. So another term of this specific gravity is relative density. That means density of any material, any liquid by density of water. So in this question, it is given the fluid used has a specific density of 0.85. That means its actual density is 0.85 into 1000. So that is the question. So please try to understand. So it's a manometer is given. So I just draw this schematic for you. Just a manometer. So it is certain liquid level. So given atmospheric pressure, and remember one thing, the atmospheric pressure, we consider the atmospheric pressure constant for a numerical problem. We consider the atmospheric pressure constant. Say this is also atmosphere, this is also atmosphere. So whatever may be the point 1 and point 2, it should remain same. It is just an assumption for atmosphere. Okay. So in the atmosphere, if it is the point 1 is here, we know that in the vertical direction there is change in pressure. That concept is correct. But for simplification, in case of air, we consider all this pressure as same value, that is atmospheric pressure. So try to solve. Hmm. So Nitish has answered it is option B. Okay. Option D. Hmm. Are you sure, Mr. Nitish? Option D is the answer. So please check your calculation. So let me think option, Mr. Let me think option C. Okay. Yes, option C is the correct one. So So this one is a similar concept like the previous one. So consider this as the manometer. So it is certain liquid level. So at this point, say this is P1 atmospheric pressure, and you are asked to find the pressure uh, sorry, at H equal to 45 centimeter. So that at that point you are asked to find the pressure P2, right? So what it is basically, so P2 should be more than P1, right? So that means P2 equal to P1 plus rho g h. So what is P1? P1 is the atmospheric pressure. So what it is given as? It is given as 96 kilopascal, and also remember this unit. So sometimes student makes mistake in the exam, while in some question kilopascal is given, or in some question only pascal is given. So accordingly you convert. Kilopascal means it is multiplied by to convert it into pascal you have to multiply 1000. Okay, so this one is P1. So if I convert this into 96 Pascal, and rho gh, rho is, say it's a, the fluid is not water because its specific gravity is given 0.85. What I have said, if the specific gravity is the ratio of density, like if it is a fluid F by water equal to 0.85, and we know the density of water is 1000. So here this density equal to 0.85 into 1000, and gravity we know 9.81, and height is, say the height is given in centimeter, so we have to convert it into meter. So there should be 0.45. So after calculating this thing, you will get most probably 3752.32 Pascal. Okay, so you can add this to one and this one, and you will get this answer as 99.75, that is in kilo Pascal. So the option C is the correct one. Yes, yes. So question 4. So I am moving to this question 5. So it's a theoretical question. So it just need your little bit of concept about this pressure and this centroid. So please try to understand this question, and after that response in this chat box. So in this question, it is asked the center of pressure of a liquid on a plane surface immersed vertically in a static body of a liquid always lies below the centroid of the surface area, because these are the four options. The first one is the in the liquid the pressure acting is same in all directions. So already you know that cannot be true, because what we have studied, in a liquid in the horizontal direction the pressure is same, but in the vertical direction it is not same. So the first option is not correct. Scientifically it is not correct. The next option is there is no shear stress in liquid at rest. The third is the liquid pressure is constant over depth. So the option C is also wrong. And the option D is the liquid pressure increases linearly with depth. So only two option is left for you to answer, the option B and option D. So that's how you need to eliminate this option. If some of you are also going to appear for this GATE exam, so try to analyze this option accordingly. So there are certain options which you can eliminate through this basic concept. So please try to answer. Option D is correct. Okay. And Nitish, Mr. Nitish, so no need to worry. Whatever you feel, you can answer. It's an interactive session. D. Okay. D. Okay. 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 Hmm. Okay. Yes, option D is the correct option. So, what is the reason behind this? So, first thing is that the center of pressure, as in the question, it is given the center of pressure there always lies below the centroid of the surface area. Why this thing? Say this is a liquid level. So, so in a 2D, what it appears to be a square or rectangle. Say assume it as a square. So its centroid should be at the, if its height is say h, so its centroid is at h by 2, right? So say, this is the position of the centroid. I am talking about centroid here. So if I am coming to this concept of center of pressure, what exactly this concept is? So see, whatever be the pressure at this point, this P2 is more, this P3 is more than this 2, and this P4 is more than this 3. So that means as we move downward, the pressure keep increasing. So the density, or if the numeric, I am talking about this value. If this value, the value is more toward the bottom. So if I take this average, so this average point will come toward the bottom, right? It should not be the center, because if this is the center line, the pressure, the total of this pressure above this line is less, whereas this total of this pressure below this line is more. So the shifting of this center of pressure should be at the bottom side. So that's why always the center of pressure lies below this centroid of the surface area. And another option is that, as we know, this pressure increases linearly with depth. So that's why option D is the correct. So Nitish, you understand this concept, Mr. Nitish? Yes. Okay. Thank you. Mm, So I'm moving to the next one. So after these classes, I will also provide this PPT. I will also share this PPT with you. So you will get a mail from this NPTEL where you will get this link. So this is our sixth question. So in this question, what is a two syringes are there having different cross section, and it is said that it is filled with water. That means both of them are filled with water, and the diameter of the smaller piston and the larger piston are given 1 and 3 centimeter, and if a force of 20 Newton is applied to the smaller piston, then the force exerted on the larger piston is. So you have to find out the force. So basically what is given? The diameter is given, the force is given. So these two things is given. So such types of problem where the diameter varies, the forces are given or the pressure are given, then we have to remember this Pascal's law. You know this Pascal law? Okay, so try to answer this question using this Pascal law. What pressure into area? No, that is not exactly this Pascal law. So whatever you said is partially correct in terms of this law. Okay, I will explain this thing for you. So just let me clarify this thing. So here in this Pascal law, what it states that in a fluid, say if it is at rest. So basically, remember this condition, terms and conditions, that is the fluid should be at rest. So if a fluid is at rest, if I apply pressure at any point, at any point, is transmitted equally in all directions. So so that means whatever say I am talking about this thing. So this is two pipeline. Okay. So this is a closed pipeline and no pressure variation is there. So no flow is there. So whatever may be the pressure at 1 and whatever may be the pressure at 2, so that should remain equal. That is the concept. So I can say that P1 equal to P2. So that is the concept. So please try to answer this question using this thing. P1 equal to P2, and rest thing you have said it correct, where force equal to pressure into area. That is uh, what option? Someone so I'm giving you 1 minute time to answer, 1 and 2 minute time. So please try to answer. Anyone? Just try to answer, or else I will solve it for you. Option A. Okay. So I have to see. Okay. So one have answered option A 60. Let's see what other students are telling. So let me solve this thing or you. Can I start? Option D. One option. Okay. Let's see. Okay, I am solving this thing. So what I can tell from this Pascal law. So here two different shearings. They are talking about two different shearings. So this is say one shearing, and also say no needle is there, because if there is needle then flow will come out. Then this law is will not be applicable here, right? So this is one. This is two. So according to this Pascal law, pressure at one should be equal to pressure at two, right? So pressure can be written in terms of force. That means force by area, F2 by A2. Okay. So I can write F1 by F2 equal to A1 by A2. Just I replace this thing. Okay. And in this question, what is it? The diameter of the smaller piston and the larger piston are 1 and 3 centimeter. Okay. So 1 and 3 means which one is 1 and which one is 3? So say I consider this one as the smaller one. So where this diameter is equal to 1 centimeter, and here the diameter equal to 3 centimeter. So this is D1, this is D2. So what I see, that is D2 is 3 times D1. Okay. So area, what it should be the area? Area is the cross section area. We know area equal to pi by 4 D1 square. Similarly, A2 equal to pi by 4 D2 square. Because it's a shearing, so its cross section should be a circular one. Generally, it's a circular one. So if I divide A1 by A2, see, these terms and these terms are equal. So I will get D1 square by D2 square. So I can write A1 by A2 equal to, in place of what is D1? D1 is 1 square and D2 is given as 3 square. See, it is in centimeter square. It is centimeter. So if you convert it into meter, it doesn't matter because it is in denominator. So that's why I haven't converted it into meter. Okay. So that is 1 by 9. So there, here I can put it as 1 by 9. So we are asked to find F2. So I can write F2 equal to 9 times F1, right? So F1 is given as 20. So 9 into 20, that means 180 should be the answer. So option C is the correct. So this concept is clear, I hope. Is this concept clear? Yeah, okay. So as this concept is clear, a simple question is for you in the next slide. Uh, so I think you can answer this one easily. So this one is the question. C is correct. Good. Hmm. So Mr. Alam has said option C. So other please try. Hmm. Yes, yes. Hmm. Why B and not C? Can anyone tell? Yes. Hi. Yes, good. That's the answer. So I think so option B is the correct option because fluid it is applicable for both liquid and gas. That's why it's fluid. Hmm. So I'm moving to the yes, yes. It's for incompressible phase. Yes. That is another important point. So this one is that. So this is another question. This is quite important. If someone is in future, if someone is interested in working in microfluidics or contact angle measurement of any droplet over some certain surfaces, so that concept you have also heard word like hydrophobic surface, hydrophilic surface, right? So this is rightly an equivalent to equivalent concept. So let me clarify this thing for you. So theta is the angle of contact. What is the initially say a li- yes, I am explaining this thing. So what is the angle of contact basically? So this is a surface. Say this is a surface. If a water droplet is forming, this is a water droplet, right? So, so this is a contact angle means it's an angle that is measured at the interface of the liquid and this surface. How it is measured? So at this point, see, I am just changing this color for you. So at this point, the contact point between this surface, liquid and this is atmosphere or gas, whatever you go. So at this point, if you draw a tangent to this curve, so we have to draw a tangent. So that is tangent, right? Similarly, at this point, you can draw a tangent, point of contact. So whatever the angle made by this surface with this tangent, that angle is known as contact angle. Is it clear? That means you have to draw a tangential line to this curve of this droplet. Okay, and and you have to check what is the angle it made with the surface. So the surface basically is the reference line. See, sometimes the surface is not flat. It may happen that the surface is like that on. Okay. So at that case, you have to take several reading, like 10 reading, 20 reading, yeah, 50 readings according to this surface roughness. And after that, you have to average out this value and have to report a fixed value. For the flat surface, one angle is sometimes sufficient, but it is advised to take at least 10 readings. Because see, if this is a large surface, if you pour water drop here, and if you pour water drop here, it happens that whatever be the contact angle at this point and whatever be the contact angle at this point, maybe it varies. There is a chance. So how will you report? That's why we will take 10 to 15 or 5 to 10 droplet and measure the contact angle, and after that averaging out all these things, we report a certain value. Okay. So what is the importance of this thing? So this theta, if this theta is less than 90 degree, that means if it is acute angle, what it represents? It represents the surface is hydrophilic. That means this surface loves water droplet. Okay. And if it is greater than 90, then it means the surface is hydrophobic. That means it hates water. It hates the liquid droplet. Okay. So here the question is about a plane meniscus. So less than 90 degree. Yes, yes, I am explaining this thing. So meniscus is basically just I am showing to see this. I need an example. See, you have seen a lens, spectacle lens, right? Spectacle lens. Uh, so there is certain angle, these types of curvature. That curvature is known as meniscus. So meniscus has certain so there are three types of generally meniscus are there. One is plane meniscus, one is concave meniscus, and another is convex. So since theta is less than 90 degree, that means acute angle. So it is in concave. Concave is a shape, and if theta is less than greater than 90 degree, then it is convex. So it is talking about the shape of the droplet. Shape of the droplet that is forming on a surface. If it is forming a concave shape, then concave shape means this shape. See, I am drawing. This is your concave shape for droplet, and this one is hydrophobic. Okay, so this one is convex shape for droplet. Is it clear? Okay. So if it is clear, can I move to the next one? Here it is plain. You see, it is said. Sorry. Okay, 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 okay. I just forgot about this answer. See, it is talking about this plane. Plane means that is there is no. Say it is a plane meniscus. Plane meniscus means theta. If theta is 90, then it's a plane meniscus. So theta is 90 means the droplet that is forming here, the angle is 90 degree. So that's why it is option D. Hmm. So if they say that it is a concave meniscus, then you have to answer theta less than 90 degree. So question can be asked like that. So if I talk about this example, say if you put water in a glass, any glass, uh, so you whatever the you just a minute, let me clear this thing and show you. See, in your household, I'm drawing you two things. So this is water in a glass. What is there? Water in a glass. If you put water, you will see this type. In the edge, the water is coming is slightly uppish, right? Have you observed this thing? In test tube, you see that this is not a flat line. There is a slightly uppish in the wall side. So that is for water. And if you pour mercury in a vessel in a test tube, and you will see that the bottom part will bulge upward. So that's why it is convex. And flat meniscus also, you in terms of vessel, the this one is flat meniscus. So this is the previous one is based on a droplet, and this is based on a test tube where I put water, mercury, and this one is for say any perfect liquid. There is no perfect liquid in this world. So if you put some perfect liquid in a vessel, then only a plain meniscus can form. But in real life, it is not possible. So now this concept of meniscus is clear or not? Huh. Yes, it is less than 90 degrees. But in normal glasses, as the volume is quite large, you will not be able to observe this thing uh, properly. But in a small test tube, you will definitely observe this thing. Okay. Angle of contact, any uh, angle of contact, and yes, there is a relation. uh, I can't exactly remember this formula, I have to check, but there is a formula. In the previous class I have discussed about this formula, but right now I can't recall this formula. So h equal to something, there is a formula where it depends on theta, the function of theta. So if you request this information, please go through the previous lecture, then you will understand this thing. Okay. So since the height is known, so you can find the volume, because already you know the radius of this vessel. Okay. So if the radius is known, height is known, then definitely volume you can find out. The volume of this portion also you can find out. Okay. So I am moving to the next. Huh. Yes, recorded has been given in the YouTube, and also the link has been shared through this mail from this NPTEL. Last 2 to 3 days back, they have, along with this feedback form, they have shared this link. So please check this mail. Okay. So this is another short question. So where it is at the atmospheric pressure head in terms of this water column is what? So what is pressure head? Pressure head, which, see, if the term atmospheric pressure means P, talking about P atmosphere, but if this term head is included, that means it talks about the height, that is H. In this formula, you remember P equal to rho g H, right? In this formula, this H is referred to as pressure head. Okay, so I can write C atmospheric pressure equal to rho g H ATM. So you need to find out H ATM. Say here it is in terms of water column. Why it is given? It is given because this rho value should be of water. If it is given in terms of mercury column, then this rho value should be in terms of mercury. So please try to answer. So, Nitish has answered option C. Okay, let's see what other is telling. Oh, okay, okay, sure. So, what I am saying is that in the question you were asked to find this atmospheric pressure head in terms of this water column. So, atmospheric pressure we know P. Okay. So, in terms of water column means C. If water column basically refers to this thing. Say in a column there is water of height h. So that height h correspond to that height h, you need to find out the value of pressure. So this atmospheric pressure, sorry, you need to find out this value of H ATM. So atmospheric pressure, you know what is the value of atmospheric pressure? So atmospheric pressure P, 1 bar. So in 1 bar we can write it exactly. It's in Newton. It is 101325 Newton. So in terms of Newton, it is 101325 Newton. Please remember this thing for calculation, because in many of the question it is required. Maybe in question it will not be given 101325 Newton. So P is given. So you are asked to find H. So we know that P equal to rho g H. So this H here is known as pressure head. Okay. So I can write here ATM plus ATM. So that's why, because they already said that it is for water. So here rho should be water. So I can write H ATM equal to P ATM by rho water into G. So P ATM is 101325, and rho, since water is given already, so I have to put the rho as 1000 into 9.81. So please calculate. You will get value near about 10.3 meter. See, if the same question is asked for mercury column, then what you need to do, you just have to change this value to 13.6 into 1000, because as we know that this density of mercury is 13.6 times that of water. So that is the difference. Is it clear? Yes or no? Hi. Yes, yes. Yes, you can take that one. Say 10 to the power, like see, um, G. For calculation, simply CT we sometimes takes it as 10 meter per second square. Some people take it as 9.81, some take it as 9.8. So basically this one is more accurate. Similarly, for calculation simplification, you can take it as 10 to the power 5, not an issue. But this is a standard value, that's why I have taken this one. And if you take 10 to the power 5, you will also get the answer near about to 10.3. That is also okay. It's up to you. So whatever value you are taking, you just write down against the question that I am assuming P ATM equal to 10 to the power 5 Newton. So mention this thing, then this thing will be correct. Not an issue if you put 10135 or 10 to the power 5. Is it clear? Huh. Thank you. So uh, others, can I move to the next one? Okay. So this is another concept. Uh, Here the question is, while measuring pressure, if we use an inclined tube manometer in place of a single column manometer, the sensitivity of the manometer is increased by a factor. It seems this question is quite new to you, right? So anyone having any concept about this manometer or anything, you know? Okay. So basically it's a measurement of the pressure. So what basically a manometer did is that it measures the pressure in terms of the difference between 2 points, or say I'm just giving you an example. So I am just giving you this concept. So a manometer, so this is a manometer. Okay, this is a manometer tube. So where, say this is point A. Okay, so in this point generally two liquid are there. So I am drawing a line here. So this is another liquid. This dotted line represent another liquid, and this indicate. Okay, I am using another color. Then that will be easy for you to understand. This green dot indicate liquid 1, and this red indicate liquid 2. So basically two liquids are there, right? Any confusion up to this? Okay. So up to this it is filled with, so I am drawing another line for you reference. Say up to this uh, there is another line. So two line is there for two liquid. So this green line indicates say water, and this red line indicates say mercury. So if you have to find out this pressure at this point, so say, so I am naming this point. So this point as B point, this one as A, this point as B, then this is at C, right? And this one as D. Okay. Up to this it is clear or not? Clear. Okay. So how I have to calculate this thing? Say in the D point is exposed to atmosphere. So pressure at D means pressure of ATM, right? Because this point is at atmospheric condition, so whatever be the pressure at D, and it should be equal to atmospheric pressure. So I consider this pressure as gauge pressure. So we know what is the gauge pressure at atmosphere. It is 0 because it's a reference line. Is it clear up to this? So after this, uh, this level you can calculate using a scale. This height, yes or no? Yes. So pressure at C, what should it be? Pressure at D plus rho G H. Say this one is H1. So if you know this height and this liquid is mercury, so here density of mercury use. So what you will get? You will get pressure at C. Yes. So pressure at C is known, and see it is at the same line. What we know that in a horizontal line the pressure remains same. So P at C and P at B should be equal. So as we find out this value of C, so already we will get this value of B. At B it is known. Similarly, this point using a scale we can find out this height. Okay, so at this point A, since point B is at bottom and point A at top, so pressure of which point is more? Pressure of B will be more than pressure of A. So I can write P of A equal to P of B plus rho. What is there? There is water, G H2. So you know H2, you know rho, you know G. Also you know, sorry, just a mistake, this one is B and this one is A. So pressure at B equal to P of A plus rho water GH2. So you know pressure at B. So pressure at B you can put. So what you will get? You will get pressure at A. Is it clear to everyone up to this? Yes or no? Okay, I guess I hope that everyone understand this concept. So see, just knowing this atmospheric pressure, we have scale. This is atmospheric pressure. We can find out this pressure at A. So that is how a manometer is used to measure this pressure of a liquid. This is for water. So if any other liquid is there, say for oil, you put oil here, you put mercury here, and accordingly you can calculate the pressure at this point. So that is how this pressure is measured. Okay, so now I am solving this problem for you. What in this question it is given? So it is given a single column manometer is given. So basically a single column manometer is looking like this type. So sometimes it is this one is a single column manometer. Sometimes you will find these types of arrangement in between in some of these cases. So but in the for a generalized case I take this one as a single tube manometer. Okay, so this one is a single tube manometer. So I have to find out this pressure at this point. So let us consider this point as 1. So this pressure equal to what should it should be? So this should be, I make it generalized. This should be rho g, say it is x. If you are facing any confusion, just tell me because it's a new concept for you. So I just consider this change as, okay, I make it simplify for you, then it will be quite easy for you to understand. So basically the difference between these two scenario, this is a incline one, say this is a single one. Just I am drawing like this one. Okay, so here just putting another color for simplification. This red line indicates water up to this portion, and this indicates mercury. So how you will calculate this thing here? So if you know, if this is your length, you know this length is L, right? So you can find out this height. This is L. You can find out if this is theta, you know this is theta. So then H equal to L sin theta, right? Hmm? L sin theta. So see, if it is a this is for inclination. If theta is this theta, if this theta is 0, then this height should be 0, right? And if this theta is 90 degree, Okay, then it is a U-tube, like this thing will look like this one if theta is 90 degree. Yes or no? Huh. So that is the thing here. So I am up to this, it is okay. So what it is given to two certain scenarios in there. So in a horizontal we know that rho for single column manometer, C manometer, I can write rho g, say this value as x, and for vertical what I have find out, sorry, and for this angular one, inclined one, what I have found out, rho g L L sin theta, right? So that thing, sorry, this is pressure. Since they both are using for measuring pressure, so same pressure, say these are giving same pressure. So if these are giving same pressure, if considering this as 1 and this as 2, what I will get, 1 divided by 2, these two pressure are equal because while measuring pressure, so I consider the pressure at both the scenarios are equal. So I can, what I will get, 1 equal to rho gx by rho gl sin theta. So these two is cancelled out. So I get L by x equal to 1 by sin theta. Yes or no? Huh. So that's why, uh, so L means what is the L? L comes from this inclined manometer. So in the case of inclined manometer, what we have? We have a term compared to this one, that is 1 by sin theta. So that's why option C is the correct option. Also you can tell this thing in like that way. Say, see if the theta is greater than 90 degree, what that indicate? That indicate, sorry, theta less than 90 degree, that indicates sin theta less than 1, right? So I can write 1 by sin theta, that means it should be greater than 1. So 1 by sin theta means L by x greater than 1, that means L should be greater than x. So also from this one I got that uh, sensitivity of which one, L for the, L is for inclined manometer. So as inclined manometer is greater than normal one, so that's why definitely it should be 1 by sin theta. That's why the answer is 1 by sin theta. So can I move to the next one? Okay. So it's another simple question after 2 to 3 theoretical question. It's another simple question. So I hope that you people will be able to answer this one. So what it is given? It is given a block of concrete weighs 400 Newton in air and weighs only 250 when immersed in fresh water. Specific weight, what is specific weight? That is relative density is given. So you are asked to find out the average specific weight of the block. Specific weight of water is given. So you are asked to find out the specific weight of block. So please try to answer this thing. I am giving you 1 minute, and after that I will solve it for you. So it's basically this Archimedes principle. Here what you need to apply, this Archimedes principle. So what this principle state? So I am just giving you hint to solve. So Archimedes principle says if we pour some body, or if you submerge some body, whatever may be the buoyancy force, it should be equal to this weight of water displaced. So that is the Archimedes principle. So Anushka is saying option B. Okay. Let other people answer. Please try to answer. Okay, I am answering this for you. So basically, see this block of concrete weight 400, it is in air, and oils when it is submerged in water. So why this thing is because this is from this Archimedes principle. So first let me calculate this weight of this concrete. So sorry, it is already given. So the concrete weight is initial weight is 400 Newton, it is given. So we know this is formula is specific weight into volume, right? That means rho g into volume, rho of the body. I mean, that means this concrete. So these two terms, let us assume this I represent it as B. The combine of these two terms as gamma B into V. Okay. So what I got, gamma B into V equal to 400. It is given. This is the first one. Then when it is submerged in fresh water, say if it is submerged in fresh water, so initially say the level of water is x. After if after dropping this or dropping this block into this water, its level will increase, right? So say it is y. So what is the difference? So this difference is y minus x. That means the level of water increase is y minus x. So accordingly, this volume is the volume of the block in the water. So the height is known, so you can find the volume, right? So that is the concept here. So when submerged in water, so its oil should be density of the block minus density of water into V. Is it clear to everyone? So that is how the displacement of water is. So that value is equal to 250. So it is given. So this is 2. So now divide 1 by 2, you will get 1 divided by 2, you will get 400 by 250. Okay. So given specific weight, which specific weight of the specific weight of water is given as 9810. So I am converting 9810, it is given. So you put it here and you will find out rho v. Okay, just put this value here. So after this class also I will share this PPT with you, and if you still face some issues or any problem about any question, you can also mail me about this doubt. I will reply through this mail. So I will provide this mail after this class. So if you put this thing here, you put the value of gamma water here, you will get this value as 26.16. That is option B is the correct option because it is in kilonewton. So that is the question. So I think you people understand this question. So can I move to the next one? Please tell. Another confusion some of the student may face is that why in case of water I have subtract this gamma W, but in case of air it is not used. Actually in case of water also the similar formula is there, that is gamma air. Always remember that the specific density of air is generally considered 0. That's why it is not mentioned here. Same formula is applied in both cases, but in case of air this value is 0. That's why it is not visible here. I think you people now understand this thing. Can I change to the next one? Okay. So this is another concept. So first read this question. This concept is a beautiful combination of fluid mechanics and uh, you have solid mechanics. You have studied about the solid mechanics, concept of moment and force balance, all these things. So this is a beautiful combination of these two concepts. So first read this question. So in this question it is given a vertical rectangular gate 2 meter wide and 2.5 meter high is subjected to water pressure on one side. The water surface being at the top of the gate is hinged at the bottom and is held by a horizontal chain at the top. So for your visualization purpose I have shown these images here. I think these images is clear to you. So it's like a dam purpose, it's like a dam. So this thing here is a support that can control this water from coming out. So and this is a rope or chain like arrangement where T is the tension in the chain. So this is the hinge and this is the hinge. So you are asked to find the tension T. So for this what you need to do, as this is water, so water will put some pressure here. right, to this gate. So this force is known as hydrostatic force. Hydrostatic force. So what is hydrostatic force? The hydrostatic force is the force experienced by the solid surface due to the static fluid. So this is the solid surface, this is our solid surface, and this is the water, this is the liquid. So the pressure the water is applying on this liquid is known as this, the force that is applied on this wall is known as hydrostatic force. Say this I represent it as F. So basically in the class you have studied this formula rho G A H. So this means this force where this force will apply, this force will apply at the, say, see, as in the earlier question I have told that this pressure, where is the pressure in the liquid, whatever be this pressure at this point, if we move downward the pressure will be more, right? So that concept we need to consider here. So what is rho? Rho here is 1000 and G is 9.81. Area, it is given 2.5 into 2. So I can write it as 2.5 into, and H is the centroid, total is 2.5. So centroid is in the middle, that is H by 2. So that means 2.5 by 2. So you just use your calculator to find out this value. Tell me what is the value. Anyone got this value? Nitish, Alam, Anushka, and Sashiti, Mr. Anyone, please try to answer. So here that is 6131245 kilo in kilonewton. So basically, better to convert it into kilonewton. So that is, so just take it like this one. 61.31 kilonewton is the force. Okay. So this thing, see, as this is our, as I have told, this pressure force is more toward the bottom. So this line, consider this pressure line. So here it is P1, this is P2, this is P3, P4, P5, P6. So 6 point I have taken for your reference. So if you average out these first 3 points and if you average out these 3 points, which value will be more? What do you think? Bottom one. So that means the yes, yes. That means the center of pressure is toward the bottom. So that's why you see this red line is toward the bottom and it is basically at h by 3. So how this thing has come, actually derivation is there. If you go through any fluid mechanics book, you will find how this derivation is there. So that indicates that it is at the bottom h by 3. So now I will take moment. Taking moment equation, moment about the hinge. So where is the hinge? Hinge is here. What are the forces apply? Here two forces are applying. One is F, this one is F, and another is T. These two forces are applied here. So see this T force is how much distance, vertical distance from this edge. So T is applying in this direction and it is at a vertical distance of h. So I can write moment from hinge is T into h. So is the force into vertical direction. Moment means force into vertical direction. So that's why it is T into h. And another force is F. So that F1 is also that F1 is how much distance from this hinge? H by 3. So I can so I can write, so I equal these two. So I cancel H. So this T equal to F by 3. What the F is given in this here? It is 61.31 by 3. So that basically it is near about 20.4 kilonewton. So that is option B. So it's my suggestion that such question, this question, if someone wants to appear for this exam, NPTEL exam for certification, you will definitely find these types of question. Maybe some other values will be given, or pattern of the question may be changes, or the shape of the liquid. See here, it is a rectangular gate. Maybe it is given a triangular gate can be given. So similar types of problem you will find in the fluid mechanics books. So please go through these types of problem. You will definitely find this question. Is it is it clear? Can I move to the next one? Okay. So this one is our next question. So what is given? So this question I represent for visualization purpose. I am showing you this image. So what actually it is telling this question, that is a two separate liquid are there, water and mercury are there, and in this liquid a rod is immersed such that some of its portion is in water and some of its portion is in mercury. So what they asked you to find, they asked you to find out this distance from this end to here, that is x. You need to find out this x. So since the total length is given as 15 centimeter, so I do not know how much portion is on the mercury and water. So I assume the portion that is on mercury be x, and whatever be the portion on the water be 15 minus x. Okay. Again, this is the concept of Archimedes principle. So from this Archimedes principle, what I can tell, this weight of the rod is equal to buoyant force for water plus buoyant force for mercury, because some portion of it is deep in water and some is in mercury. So what is given in the question? It is given relative density is given, right? So relative density of the rod is 7.4. So what should be the weight? Weight should be, can anyone tell what should be the weight of the rod? Hmm, 7.4 into, say, okay, Okay. Okay. See what other sudden. So how you have calculated, just tell. 7.4 into, why 7300? Uh, Not necessary. Actually, this weight of the rod, what is given? This 7.4 as the relative density. What is relative density? Relative density means rho of this rod by rho of water is 7.4, right? So, what is rho of R? It is 7.4 rho, right? I represent rho of water as only rho. So that means here, for your clarification purpose, I can say rho G. And what is the rod of the height of the rod? It is 15. Okay. You see, it is centimeter. So see, I consider all these things in centimeter. That's why I am not converting into meter. Right? Whether it is clear or not. So what I am saying, it means rho GH. Here rho is the rho of rod. So this rho of rod is 7.4 rho. That is I am written into G into 15. 15 is the total height. Since it is sorry, into volume. Sorry, not height, into volume. So this height into area. So area means this cross section area of the tube. I don't know this cross section, so I have taken it as A. Now for water. In case of water, what it will be? Only 15 minus x is in the water. So I can write, what I can write here? So this means in this portion rho G, since it is water, so it is rho G 15 minus x into A. That is the volume. Height into area is the volume. Yes or no? So in case of mercury, it should be, what is the mark? In case of mercury, we know 13.6 into water, and so I can write 13.6 rho G x into A. So see, A is common in all sides, so I can cancel A. Yes or wrong? So only rho G is also common in all sides. So ultimately I get it, the simplified equation is 7.4 into 15 equal to 15 minus x plus 13.6x. So you please solve this one, you will get x equal to 7.62. So option C will be the answer. Please check. So, so this is another important question. So this is based on the buoyancy force. So please practice this thing also. So another last two question is there. So it will take another 5 to 10 minutes. This is simple question. So can I move to the next one? So if you missed a few of this question or lecture, you will get the link uh, through the mail. So this is the question. So here basically in this question what is say that two vessels are there. In one vessel the area is twice that of the other, but the height in one case is, if the height in one case is h, in another case it should be 2h. So I think these two case 1 case 2 picture is clear to you. Hmm. Yes. Uh, so what has been asked in this question? So in this question, this pressure P1, P2 denotes the pressure exerted at the bottom. Uh, so basically, this is uh, your P1. This is your P2. So can you find out P1, P2? P1 equal to rho GH, not A, only rho GH. A is for force. Hmm. Alright. So and rho 2 is rho G 2H. So what I will get? P1 by P2. If I divide, uh, 1 by 2. So 1 by 2. So P1 is zero point 0.5 times of P2. So that means I can cancel out option A and option B. So answer can be among option C and option D, right? Huh. So also they have talked about this force. So F1 and force exerted at the bottom of the container. So what is force? F1, uh, pressure into one area. So Miss Anushka, you tell what should be the value here for F2. Miss Anushka, this one is A and this is P2 into 2A, right? So what is P2? We got P2 equal to zero point 0.5 P1. So that means here it is P1A. So that means F1 and F2 is, so option uh, C is the correct option. Uh, so though I have here I have mentioned option D, it is by mistake I have written into option D. It should be option C. Option C is the answer. Okay. So the last question for today. So this question I think you will easily able to answer because this is based on the concept that I have discussed in the first 5 questions. So please try to answer. So see in the chat box I have I provided my mail ID. Have you got this mail ID? So if you have any question, any concern about any concept or anything thing. If you find difficult, you can mail me through this mail ID. So I think you have got this mail ID. Okay. So for this last question, so what it is given in this question? It is given this atmospheric pressure at the free surface of a freshwater lake is given this one. So that means P ATM is given as 101325 Pascal is already given. Maybe it happens that this value is not given in most of the question. You have to remember this value of atmospheric pressure. That would be better for you. So you are asked to find this gauge pressure and absolute pressure. So we know what is gauge pressure. P gauge, that means rho G H. No, zero, that is gauge pressure is zero for atmospheric one. Say this is atmospheric pressure. If the corresponding gauge pressure I find out, then it is zero. Whatever you said, it is correct, but for atmospheric pressure. And normally it is the normally it's the gauge pressure. Here I am talking about gauge pressure at 2 meter below. At 2 meter below. So that rho is there is 1000 and G is 9.81 and H is 2. So I will get 19620 Newton per meter square. So that means 19.6 kilonewton per meter square. So the initially the first is the gauge pressure. So see where 19.6 is given only in option A. So you get the answer. No need to solve the second one. Still we will solve this second one. So second one is the absolute pressure. What we know? This absolute pressure means P ATM plus P gauge. So see P gauge I have written it in terms of kilonewton. So I also convert this ATM in terms of kilonewton. So if you convert Pascal, what is Pascal mean? Pascal means Newton per meter square. So if I convert it into kilonewton, then it should be 101.32. Yes, and for gauge it is 19.6. Yes. So what I will get 120.945, right? 620. This is 620. That's why. So that is this kilonewton per meter square. So option A is the answer. So do not confuse among this gauge pressure, absolute pressure, and atmospheric pressure. So it's a common mistake to many of the aspirants. So please go through this thing. Any question, any doubts or anything? Huh, huh. Yes. And please tell. Hmm. Please. Yes. Huh. Huh. Hmm. 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 Uh, huh. Viscosity, actually, there is an index, viscosity index. What I remember in a research paper, I have find out certain types of formula regarding this viscosity index. So here there they have mentioned how to calculate this thing, and also they have validated this thing with some of their experimental data, um, like with few liquids. So that thing is there. What I remember that thing is there, but I haven't recall this thing, this formula right now. So please mail me. So I'll send you this. If I got this paper, I will definitely send you. So better please send a mail to me. Else I will forget. Okay. Thank you. Any more question? Anyone? Uh, so I think you people understand this concept in the class. Uh, so okay, I consider that everyone understand this thing. So this is up for today. Can we wind up this? Yes, yes. Hmm. Any- So yes, see, what I will suggest, the first thing is that please go through this lecture that has been uploaded in a weekly basis. And next, try to solve this assignment and also this interactive class like today, and two more interactive session are there. Most probably they will discuss the same thing. I don't know. So you can attend this thing. Or and another thing is that for books, you can use conventional books like Sangers and Bowles, or you can use Mechanics of Fluid by M.C. Potter. Also, you can we have books like Kurmi, and these are not standard books; these are common books. So you can in online also you can find a lot of books. So please go through this book to try to solve the numerical through logic, not like just remembering this formula, put this value. uh, what I will suggest you, uh, just try to understand what this question tells, and also visualize the schematic. Like for every question, most of the question, please try to draw schematic, and then that will help you to clarify this concept. And after that, still if you find any such types of problem, maybe related to concept numerical, you can mail me. I will definitely help you. Okay, that is the thing. Okay, any more queries? Thank you thank you for joining the class. We hope that we will meet on the next Saturday at the same time. Okay, bye. Uh, Thank you. Bye.